Today I'm going to start working on a metal version of the classic turning saw. Unlike a standard frame saw, which usually has a fixed blade, with a turning saw the blade is held with handles that rotate inside the frame, so the blade can be oriented in any direction. They're usually all made out of wood and they have some kind of a turnbuckle to tension the blade. But as much as I like the look of these saws, I find them a little bulky, and having to tension the blade all the time is a bit of a nuisance. So what I'm going to be doing is replacing the wooden frame with a solid metal one. The wooden handles are going to rotate inside of metal sleeves that are attached to the frame, and the spring of the frame is going to keep the blade under permanent tension. So basically this is a large version of a coping saw that has a much stronger frame. I'm going to be building the frame out of 1/4 by 3/4 flat bar, and the total length of this piece is 26 inches. The first thing I'm going to work on is the curved transition between the handle and the frame of the saw. And that's simply done by forcing the end of the bar into a really short bend. Here I'm hammering at about a 45-degree angle, and I'm just concentrating on the top corner of the bar, so it just forces the tip of that bar to wrap around the edge of the anvil. I don't want to thin out the main body of the frame at all, so I want all that material to just start wrapping around the edge. And then once I have that point developed, I just start driving the material back so I can square up the other side of the bar. And as always, when I'm upsetting, I try to use the lightest hammer that I can. It just keeps the impact right at the end where you need it, and it doesn't deform the piece as much as a heavy hammer does. When you use a heavy hammer, when you try to upset, it just tends to push the material rather than tap it into shape. And when you're shaping a square corner like this, you are predominantly shaping the square corner. It takes a surprisingly little amount of material to turn a rounded corner into a square corner. So you really don't need a heavy hammer, swinging at arm's length to get the job done. And of course you do the same thing on the other end of the bar, and just make sure that both feet are pointing in the same direction. So now the ends are done, and the next thing that I have to do is lay out where the square corners are going to be. So I have the center of the bar marked, and everything from here on out is going to be measured from that center mark. The marks that you see me putting on the ends of the bar where the square corners are going to be located are just used to position the bar in the fire. I want to make sure that that location is in the hottest part of the fire, and I have an equal amount of heat around that square corner. When I'm forging the square corner and I want to establish the exact location of that corner, I'm going to be using a set of dividers from the center line of the bar and measuring out to the square corner. I'm using a chalk mark because if I put a center punch mark here, that's going to be harder to deal with later on. So here's the formula that I'm using. X is half of the dimensions of the inside of the frame, and it has to be an exact measurement because I'm using a manufactured saw blade, so the saw frame has to fit the blade. I'm not going to be able to make a blade fit the frame. The dotted line represents the center line of the bar, and I'm going to be measuring the position of this corner where that center line bends around at the miter. So the top measurement that says X plus 3/4 Y, that is where I need to start the bend so that when I'm done the upsetting, I get my X measurement exactly right. So for this example, I figured out that I was going to need to add 1/4 of the width of the bar, which is the Y dimension, to get the corner to fall in the right position. So x plus 1/2 y gives me the finished position of the corner, and adding 1/4 to that, x plus 3/4 y, gives me the starting location of that corner. And I established this formula through testing. I took the bar stock that I was using, I bent a square corner, and then I measured very accurately the starting dimensions that I had and the finished dimensions that I had, and I was able to establish how much I needed to move the center mark over to get the finished dimensions that I was looking for. They may be different with other corners. This is not a universal formula by any means. It's just, what works here, and it may be very close to other bends, but if you need something that fits exactly, you have to test and establish what that measurement actually is. There's no real way around it. If you want the accuracy, you have to test with the material that you're using and the application that you're using and figure out the formula right then and there. So as you can see here, the initial part of this bend is a fairly slow process. You have to take your time, bend the bar a little bit, compare it with the caliper settings, and then adjust your bend as you go to make sure that you get it in the right location. And again, this caliper setting gives me the starting location for that bend so that when I'm finished the square corner, it'll line up exactly with the mark that I need. So here I'm using the caliper settings that I used to forge the initial location of that corner, and you can see how it's crossing the center line by the 3/16 that I needed to add to get this square corner in the right position. And here I'm just confirming with a tape measure that the center line falls on 7 inches, which is what I was aiming for. And now that that checks out, I just repeat this process for the other side. The final thing we need to check on is to make sure that the legs are the same length. They should be. We established the center line from the finished dimensions of that forging, and we worked from the center line on everything else. So they should be the same length, but if they're not, you can take the longer leg and take a heat in the center of that leg and upset it slightly, and that way you can make minor adjustments to the length to get everything right. A little bit of an upset in the center of the leg like that won't be noticeable, but you can take up a surprising amount of material and make whatever adjustments you need to do to get everything to sit just right. Hi, I'm Dennis, and thanks for watching. As most of you know, for the past few years I've been producing YouTube videos on a part-time basis. I am now looking to turn that hobby into a full-time job, and for that I really need your help. A small monthly contribution from a really small number of viewers will generate the income that I need to achieve that goal. So if you're interested in the work that I'm doing and you want to lend your support, please click on the Patreon icon at the bottom of the screen. Thank you. We'll see you next time.